Greetings and welcome to the PLSQL channel, a series of video trainings in the Oracle PLSQL language. My name is Stephen Feuerstein and I'm a PL/SQL developer just like you. This lesson is a part of my series on writing maintainable code, and the topic is defining, following, and verifying standards. Some quick reminders. You find available at PLSQL Obsession, toadrule.com/sf, all the code that I'll be demonstrating, all that I use to demonstrate aspects of my lessons, and PowerPoint documents supporting my various lessons. So if you visit PLSQL Obsession, click on Demo Zip, you can download the zip file containing all the files that I've run in my lessons for demonstration purposes. Training seminars and presentations will give you access to the underlying PowerPoint resources. Make sure you're comfortable with the material covered in the previous lessons in the series, which is not much, the introduction and overview, and especially focusing on the importance of regression testing. So please do watch that introductory video before continuing on with the series. Now in this lesson I want to talk about the importance of standards-based development and the importance of establishing a strong foundation of standards upon which all your code will be built so that everybody writes code in the same way rather than their own way, which makes the code very difficult to understand. What we want to do is standardize the way everybody on the team writes their code. Then we'll talk about how to make it easy to follow standards. All too often standards are just documents, and in fact I'm going to show you some documents that you can use. But documents are passive, and usually what happens is that people read them, maybe they actually study them and learn some of them, but then the document goes into a drawer. And people generally don't integrate those standards into their day-to-day programming practices. And what we have to do is help developers establish new habits based on those standards. And finally, it's very important to verify that the standards are being followed. If nobody checks, if I publish a document with 100 standards in them, and after a while the developers realize that nobody's actually checking to see if any of the standards are followed, chances are those standards will be ignored. Not because developers are bad people or are doing it out of any sort of maliciousness, but because we tend to fall back on the easiest path of development, which is to follow the habits that we've always been following for the previous years. And so the standards don't get followed. So these are the topics I'm going to cover generally in this lesson. And just as another high-level comment regarding standards, my experience has been that many developers don't like standards. They tend to resist standards. It's like they don't like being told what to do. Don't tell me how to write my code. I know how to write code. I've been doing it for 20 years. And the point behind standards is not to force people to follow a certain way of doing things that violates their view of the right way to do things. It's really to decide in advance on all the trivial aspects of writing code that are not that important to you. In other words, you really shouldn't care how the variables are named. That's not a critical aspect and the most enjoyable and rewarding aspect of programming. What you should care about is getting all that kind of stuff out of the way, how you name things, how you format your code, etc., and let you focus on the really interesting aspects of your application development, which is meeting user requirements. So don't fight against standards, embrace standards, and this lesson will talk about how and why that will help you so much. So first of all, at a very high level, what should be standardized? Now, there are many, many aspects of writing software, of building applications that need standardization and attention. I'm focusing merely in the aspect of writing the PL/SQL code. And my feeling is at a minimum, you should never start writing a new application unless you set standards in the following three areas. First of all, basic coding standards and naming conventions. It's not a big deal to decide how variables should be named, but there should be a decision made about things like that. Second, how to handle and log errors. When things go wrong, it's really important that all the information that's needed to figure out the problem is recorded and that we communicate errors properly to our end users. And finally, how, when, and where to write SQL statements. PL/SQL programs are database programs. They interact with the underlying database, the tables, through SQL. And it's important to standardize how we write that part of our application. So don't start coding without coding standards, figuring out what you're going to do about managing errors, and writing SQL. Let's look at each of these in a bit more detail. So basic coding conventions and naming standards. So I'm not going to go over in detail different standards, different naming conventions for variables and so on. It's not a good use of your time on a lesson. And really it's a matter of simply having a document that you can use to drive the process. So what I've done instead is set up on PLSQL Obsession a standards area. And I offer a couple of variations there for you. So visit PLSQL Obsession, click on PLSQL Standards. And you'll find here, at this point, 3 different standards documents, and maybe there'll be more over time. I've put together a document with my basic ideas around naming conventions and coding standards. A fellow named Bill Coulomb, a PLSQL developer of many years, has developed a starter framework for PLSQL development, and he's written a document to define that framework and tell you how to leverage it and also his standards behind them. And Travadis, a big consulting firm in Europe, has published a set of PLSQL and SQL coding guidelines, which they've shared with us. So you can download any of these, and I suggest you do take a look at them. Let's take a brief look now. Let's start with mine if I can find it. I'll get there eventually. There we go. So just in terms of the contents, principles underlying my standards, naming conventions, general guidelines I try to follow, naming conventions I reject. The point of this document is more to give you some perspective on how to write standards, how to decide on standards, what principles should guide you. So I encourage you to check out the high-level principles. Take a look at my naming conventions, see if they make sense to you, use them if they do, change them if they don't, and then check out some of the others. So here's the Travadis PLSQL and SQL coding guidelines. Very nice document, very detailed. You'll find lots of great information here, a fair amount of overlap with what I've done. I even give it my imprimatur of support. And again, lots of details. Coding style, naming conventions, language usage, what elements of the language to use and how best to use them. Lots of good stuff here. And finally, Bill Coulomb's starter framework. He talks about some general development rules, how to set up your database programming environment, how to name your identifiers, working with stored objects, style and formatting. So again, lots and lots of content for you to use. And my feeling is, why write it yourself if you've got a starting point that will do most or all of what you need? So check out those options, see if they make sense to you. If you have your own document that you have found useful and you'd like me to post it on my PLSQL standards page, well, send me an email, send me the document, and we'll put it up. But the most important thing with your standards is how we go beyond paper-based standards and the conventions, and instead work on changing habits, making these standards more active. And one of the best techniques I found for doing that, and a way to standardize in a deeper sense the way you write your code, is to avoid starting with what I would call the white screen of productivity death. In other words, okay, Stephen, time to write a new program. I click on my edit button and I end up with a big white page, and I write create or replace package, new package is, and on and on and on and on and on, writing and writing and writing code. It's a very unproductive way to write code, and also it means that there's virtually no chance that you will standardize the way that code is written. Here's an idea for an alternative. Use code templates. Just about every IDE out there, Toad, SQL Navigator, SQL Developer, PLSQL Developer, etc., all have one or another form of code snippets, code templates, code libraries, in which you can access predefined templates as a starting point for your code. And what I want to do is demonstrate an idea of one example of doing this with my standard package format, in which I provide standard program headers, pre-inserted initialization and cleanup stubs, reminders about our best practices, calls to our application standard error manager. Let's take a look. So when I'm writing a new package, rather than create or replace, package, this and that, I can type std pkg, press Control Space. Toad will find the template that matches that abbreviation, and I can then specify values for my different parameters, my package name, and I'm going to do that. For each one of them, I'll call it Pilch for PLSQL channel. Press OK, and it creates a starting point for my package. So there's my package specification with my standard header, with my initialization procedure predefined. May or may not make sense for my package, but I've got it there. So that's nice. It's nice having standard headers, but more importantly, I've created a template for the package body that goes below the surface level of standards and naming conventions and provides ideas about how to structure the code itself. So there's my initialization program, which does nothing by default, and it's called in the initialization section of my package. Again, I might take that out if I don't need to initialize, but it's a reminder that that's how I can initialize my package, and it's important to put all that code into its own little initialize procedure. And then I've created a template for procedures and functions. Let's take a look at the function. Obviously, there's lots of things that I need to replace when I finalize my real code, but I've got my little modification header or program header. And in addition, I reinforce what I would consider to be some key best practices in my PLSQL structure, some of which we'll be talking about in this series on maintainability. For example, I think that every function should have just a single return in its executable section as the last line in that block of code. It should have its own little initialize program and cleanup program. And I've created these local modules, a key feature for maintainability that I'll discuss as the last lesson in the series. So procedures within procedures that initialize and do cleanup. So assert or check the values of my assumptions, initialize my local variables, all that kind of stuff. Instead of putting it into my main body of code, I hide it into my initialization section. Cleanup. The advantage of having a separate cleanup program is that I can remember to call it here when I'm cleaning up in my main body of code, and also cleaning up when something goes wrong. We often forget to do that. So this is a way of reminding me and everybody who starts a new package, don't forget to clean up everywhere in your code. In addition, if I need to handle errors, we've decided that the standard in our environment is the Quest Error Manager, so I've got a call to the raise error program in the error manager in the exception section to encourage people to follow the standard. Obviously, we can write the standard, people can read about it, but chances are they're not going to put it in there unless they're really committed to following the standards. But it's very likely that if it's in there from the start, they won't take it out to do something else. They'll likely follow the standard because we've provided the starting point for them. So that's the basic idea here. Provide a structure of the program that reinforces best practices, follows the naming conventions, follows the recommendations for making sure you clean up in successful and failed status. And also here's an example of including a checklist, which is a very common technique for reminding people of the right way to do things. Every time they start a new program, they get a reminder. Use bulk collect and for all for any multi-row operations in SQL. Hide complex rules behind functions. Hide your SQL statements behind a table API, etc., etc., etc. Of course, they should take this out when they write their code, but the point is that you get a good starting point, and everybody's writing code that looks the same, is structured the same, not only at the surface level, but down below the surface. So that's an example of using a template in Toad. Every single program, every single tool works differently. In Toad, I can just grab whatever code I've got, put it in my clipboard, copy it to my clipboard, go to my code editing options, and go into code templates and create my template. And these templates are great not only for these kinds of standardizations, but also for acceleration. So if I want to write dbmissoutput.putline, I just write do-pl, control space. If I need to get the format error stack to get the error message, I just write fes, format backtrace, control space. So if you find yourself writing code and saying to yourself, oh, I can't believe I have to do all this typing. Why did Oracle make the name of this program so long? Well, stop. Take whatever code you're writing over and over again that you don't want to repeat and move it into your templates, and then invoke it instead of writing it over and over again. So these templates are great, not only to get people looking at and building code in a different way and far below the skin surface of your code, but also to improve your productivity. Also, don't manually format your code. In the bad old days, and in fact I think you'll even see some tips on formatting inside the documents I just showed you, the standardization documents. In the bad old days, we would manually format our code, but hopefully you're working with an IDE, some kind of developer tool that will automatically format your code for you.